Just after 5 in the morning local time, seismometers scattered across the globe picked up a significant jolt originating from one of the most remote, least populated stretches of ocean on the entire planet. A magnitude 6.2 earthquake struck in the South Atlantic Ocean, roughly 113 kilometers west of Coronation Island, near the edge of Antarctica, in a stretch of water most people couldn't point to on a map if their life depended on it. No populated coastline sits anywhere close to this epicenter, and as of the latest reporting, the quake wasn't felt by anyone at all, simply because there's essentially nobody there to feel it. But a magnitude 6.2 earthquake is still a genuinely significant release of energy, and the region where this one struck happens to be one of the most seismically active and scientifically fascinating corners of the entire planet. A place where 3 tectonic plates grind against each other in ways that produce earthquakes on a remarkably regular basis. Let's break down exactly what happened, where this quake fits into the broader tectonic picture of the Scotia Sea region, and why this particular corner of the world quietly produces significant earthquakes far more often than most people realize. If breakdowns like this help you understand what's actually happening when these headlines hit, go ahead and subscribe now. Let's get into it. Let's start with the specifics, because getting the location right actually matters a lot here. This magnitude 6.2 earthquake struck in the early morning hours local time in the South Atlantic Ocean, roughly 113 kilometers west of Coronation Island, part of the South Orkney Islands, a small, largely uninhabited island group near the edge of Antarctica. The depth of the quake wasn't immediately confirmed in early reporting, though earthquakes in this general region frequently occur at relatively shallow depths, given the type of plate boundary running through the area. Monitoring networks tracking global seismic activity confirmed this was the strongest earthquake recorded anywhere on the planet. Within the surrounding 24-hour window, which is exactly why it's drawing international attention, despite occurring somewhere so remote that the shaking itself likely went completely unfelt by any human being. So why does an earthquake this size happen in a stretch of ocean that most people assume is geologically quiet, simply because it's so far from any major city? The answer comes down to a genuinely fascinating piece of plate tectonics that most people have never heard of, called the Scotia Plate. This is a relatively small tectonic plate wedged between South America and Antarctica, and it's bordered by not one but several actively deforming boundaries, making the surrounding Scotia Sea one of the more geologically complex and consistently active regions anywhere on Earth. To the east of this plate sits the South Sandwich subduction zone, where the South American plate is actively being forced underneath the smaller Sandwich microplate, a genuine subduction system capable of producing significant earthquakes in its own right, similar in basic mechanism to the subduction zones, responsible for some of the largest earthquakes ever recorded elsewhere in the world. To the north and south, the Scotia Plate's boundaries behave more like transform faults, where plates grind past each other horizontally rather than one diving beneath the other, a mechanism similar to California's San Andreas Fault, just playing out beneath frigid, mostly uninhabited waters instead of a densely populated coastline. This latest magnitude, 6.2 earthquake, fits squarely within that broader tectonic picture, striking in a zone where the boundaries of the Scotia Plate, the South American Plate, and the Antarctic Plate all interact in a genuinely complicated three-way relationship. Earthquakes in this general region are common enough that seismologists consider this one of the more reliably active seismic zones on the planet, even though it rarely generates the kind of sustained public attention that earthquakes near major population centers receive. In fact, if you look back through recent seismic activity in this specific corner of the South Atlantic, this magnitude 6.2 event isn't an isolated anomaly at all. Earlier this year, a magnitude 6.0 earthquake struck in nearly the same general area, near Montague Island in the South Sandwich Islands, and earthquakes in the magnitude 5 to 6 range occur here with real regularity throughout any given year. This region essentially produces a steady background hum of significant seismic activity that simply doesn't make international headlines most of the time, precisely because there's nobody nearby to be affected by it. It's worth putting this specific earthquake in the context of just how differently the same magnitude number can play out, depending on where it strikes. A magnitude 6.2 earthquake hitting a densely populated coastal city could potentially cause significant structural damage and casualties depending on building codes, depth, and proximity to population centers. A magnitude 6.2 earthquake hitting 113 kilometers off a remote, largely uninhabited Antarctic island group essentially becomes a scientific data point rather than a humanitarian concern, precisely because the fundamental equation determining an earthquake's real-world impact always comes down to the same core factors. Magnitude alone tells you almost nothing without knowing depth, location relative to people, and the vulnerability of whatever structures happen to be nearby. In this case, there simply aren't structures nearby at all. which is exactly why automated damage assessment systems tracking this event would almost certainly classify it at the lowest possible risk tier, indicating no expected casualties or significant damage, not because the earthquake itself was small, because the surrounding area is essentially empty. That said, it's worth addressing the one genuine question this kind of offshore earthquake naturally raises, which is tsunami risk. Any earthquake occurring beneath or near an ocean immediately prompts the question of whether it could generate a dangerous wave. And it's a reasonable question to ask, given how consequential an underwater earthquake can be under the right conditions. In this specific case, given the earthquake's location along a complex boundary zone that includes both subduction and transform fault characteristics. The actual tsunami risk depends heavily on the specific type of fault movement involved, something that typically takes seismologists some time to fully characterize after an event like this. Transform fault movement, where plates slide past each other horizontally, generally doesn't displace the seafloor vertically enough to generate a significant tsunami, while a subduction-related rupture with substantial vertical displacement can. Given the remote location and the specific characteristics typically associated with earthquakes in this part of the Scotia Sea, this event doesn't appear to have triggered any tsunami warnings or advisories, though monitoring agencies covering the Southern Ocean and Antarctic region would be the ones to issue any formal alert if the situation warranted it. It's also genuinely worth understanding why a place this remote gets monitored so closely by the global seismic community in the first place, even though almost nobody lives anywhere near it. Scientific interest in the Scotia Sea region extends well beyond just tracking individual earthquakes as they happen. This area serves as a genuinely valuable natural laboratory for understanding how small tectonic plates behave when they're squeezed between two much larger ones, since the Scotia Plate's unusual geometry and its combination of subduction and transform boundaries all within a relatively compact area gives researchers a chance to study processes that are harder to observe cleanly in other parts of the world where boundaries are more spread out or obscured by thick sediment and human infrastructure. The South Sandwich Subduction Zone specifically has drawn scientific attention because it represents one of the more actively studied subduction systems in the Southern Hemisphere, and understanding how it behaves helps researchers refine broader models of subduction zone mechanics that get applied to far more consequential, densely populated fault systems elsewhere in the world, including places like the Pacific Northwest and Japan. There's also a broader statistical point worth making here, because a magnitude 6.2 earthquake showing up in the news cycle can sometimes create a misleading impression about how unusual an event like this actually is. On any given day, global monitoring networks typically detect somewhere in the range of 1 to 2 earthquakes of magnitude 6.0 or higher somewhere on the planet, alongside dozens of smaller but still notable earthquakes in the 4.0 to 5.9 range. In the 24-hour window surrounding this particular event, monitoring services recorded roughly 1 earthquake of magnitude 6.0 or higher, 9 in the 5.0 to 6.0 range, over 50 in the 4.0 to 5.0 range, and hundreds of smaller quakes below that threshold, a pattern that's genuinely typical for global seismic activity on an average day rather than representing any kind of unusual spike. What made this particular magnitude 6.2 event newsworthy wasn't that it was statistically remarkable in isolation. It was simply the strongest earthquake recorded anywhere in the world during that specific window, which is exactly the kind of superlative that reliably generates headlines regardless of how routine the broader pattern actually is. It's also worth touching on why earthquakes near Antarctica specifically tend to generate a particular kind of curiosity, separate from the pure seismology involved. Antarctica and the surrounding Southern Ocean occupy an unusual place in the public imagination. Remote, difficult to reach, sparsely studied, compared to almost anywhere else on the planet, and generally associated more with climate research and penguin documentaries than with active tectonic hazards. But the reality is that the boundary zones surrounding the Antarctic Plate, including the Scotia Sea, the South Sandwich Subduction Zone, and various spreading ridges further out, are every bit as tectonically active as boundary zones anywhere else on Earth. The difference is almost entirely about visibility and consequence rather than actual geological activity. A magnitude 6 range earthquake near a populated coastline generates news coverage, damage assessments, and public concern. The exact same magnitude earthquake near Antarctica generates a data point in a seismological database, and, occasionally, a brief news mention, noting that it was the day's strongest quake worldwide. None of this means earthquakes in this region are entirely without consequence for anyone, though, and it's worth being precise about that rather than treating the area as entirely inconsequential. Scientific research stations do operate in and around Antarctica and nearby islands, staffed by researchers, studying everything from climate patterns to wildlife to geology itself. And while this specific earthquake's epicenter sits far enough from any research station that no impact would be expected, Seismic activity in this region is something scientific institutions operating in the area do track as part of their broader safety and research protocols. Ships transiting the Drake Passage and the broader Southern Ocean, including research vessels, fishing fleets, and the occasional cruise ship venturing toward Antarctica, represent another category of potential exposure. Though a magnitude 6.2 earthquake at this depth and distance from shipping lanes would be extremely unlikely to pose any meaningful risk to vessels in the area, since the open ocean itself doesn't experience the kind of destructive shaking that makes earthquakes dangerous on land. It's worth explaining a bit more about how seismologists can confidently say an earthquake this remote was still accurately located and measured, because it's a fair question given how far this epicenter sits from any dense cluster of monitoring stations. Modern seismic networks rely on a global web of instruments, many of them thousands of kilometers away from any given earthquake. And by comparing the arrival times of seismic waves at multiple stations around the world, agencies can triangulate an epicenter's location and depth with real precision, even when the event happens somewhere as isolated as the Scotia Sea. This is part of why global seismology has become so much more reliable over the past few decades. The density and sophistication of the worldwide monitoring network has grown to the point where even an earthquake in one of the most sparsely instrumented regions on the planet still gets located, measured, and cataloged within minutes, feeding into the same global databases that track every other earthquake happening anywhere in the world that day. It's also worth taking a moment to appreciate just how unusual the Scotia Plate itself is from a pure geology standpoint, because it's genuinely one of the more unusual tectonic features on the planet. Most major tectonic plates are enormous, spanning huge portions of the globe, but the Scotia Plate is comparatively tiny, squeezed into the gap between South America and Antarctica, largely because of the peculiar way those two much larger landmasses have drifted apart from each other over tens of millions of years. As that gap opened, the Scotia Plate essentially got pulled and stretched into existence, along with a scattering of small islands, including the South Sandwich Islands in South Georgia, that mark the visible surface expression of all that underlying tectonic complexity. Studying a small, oddly shaped plate like this one gives geologists a genuinely useful, natural experiment, since its boundaries interact with two much larger neighboring plates in ways that help researchers understand the broader physics of how plates deform, stretch, and eventually break apart or collide over geological time. There's also a climate and oceanographic angle to why scientists keep such a close eye on this particular region beyond just the tectonics themselves. The Scotia Sea sits directly within the path of the Antarctic circumpolar current, one of the most powerful ocean currents on the planet, and the underwater topography created by this same tectonic activity, including deep trenches and volcanic island arcs, plays a meaningful role in shaping how that current moves and mixes water around the Antarctic continent. That circulation, in turn, has genuine implications for global climate patterns and the marine ecosystems that depend on nutrient-rich water being pushed to the surface in specific locations. It's a good example of how a seemingly isolated tectonic event in a remote ocean region can actually connect back to much larger scientific questions extending well beyond seismology alone, touching on ocean circulation, marine biology, and even long-term climate research happening in the same general part of the world. So what's the actual takeaway from a story like this one, especially for anyone watching from somewhere nowhere near the South Atlantic or Antarctica? First, it's a good reminder of just how constantly active our planet actually is beneath the surface, with earthquakes in the magnitude 5 and 6 range occurring somewhere in the world essentially every single day, the overwhelming majority of them in locations far enough from population centers that they never generate meaningful news coverage at all. Second, it's a useful illustration of why magnitude alone never tells the complete story of an earthquake's real-world significance. The exact same magnitude, 6.2 rupture that generates a brief international headline when it strikes near Antarctica would represent a genuinely serious, potentially damaging event if the same energy release happened beneath a coastal city instead, and understanding that distinction is exactly what separates informed interpretation of seismic news from simply reacting to a scary-sounding number. Third, this kind of remote earthquake is a good opportunity to appreciate just how much of the planet's tectonic activity happens completely outside human awareness, in places like the Scotia Sea, the mid-ocean ridges, and countless other boundary zones scattered across the ocean floor, all of it contributing to the same constant, ongoing process of plate tectonics that shapes the entire surface of the Earth over geological time, whether or not anyone happens to be nearby to notice. I also want to be clear about what remains uncertain in the immediate aftermath of an earthquake like this one, because that honesty matters just as much here as it does with any other seismic event. Precise depth data, the exact type of fault movement involved, and any potential for aftershock. Activity in the surrounding region typically take additional time to fully characterize after an initial report like this, especially in an area with a sparser network of nearby seismic monitoring stations compared to more heavily instrumented regions closer to population centers. As more detailed seismic data comes in over the following hours and days, agencies like the USGS typically refine their initial assessment, which is worth keeping in mind if any of the specific numbers around this event shift slightly as additional analysis comes together. I'd genuinely like to know what you think about a story like this one. Does an earthquake happening somewhere this remote, in a place most people will genuinely never visit or think about, still feel like something worth paying attention to? Or does the total absence of population nearby make it feel more like a curiosity than a real event? And if you've ever been curious about the geology of Antarctica and the surrounding Southern Ocean specifically, I'd love to hear what draws your interest to a part of the world most seismic content tends to overlook entirely. Drop a comment and let me know, because I think remote earthquakes like this one are genuinely one of the more interesting corners of seismology, precisely because they get so little attention relative to how consistently active the region actually is. That's the story behind this latest magnitude 6.2 earthquake in the South Atlantic. A genuinely significant release of tectonic energy occurring along one of the most consistently active and scientifically fascinating plate boundary systems on the planet, the Scotia Plate wedged between South America and Antarctica, striking in a location remote enough that it likely went entirely unfelt by any human being, while still standing as the strongest earthquake recorded anywhere in the world that day. It's a solid reminder that our planet's tectonic activity never actually stops. It simply mostly happens somewhere nobody's watching. If breakdowns like this help you make sense of seismic news from every corner of the globe, not just the headline-grabbing ones near major cities, hit that like button. It genuinely helps more people find these updates when they matter. Subscribe if you haven't already, and turn on notifications so you catch the next update the moment new seismic activity develops anywhere worth watching. I'll keep tracking this region and every other active zone closely, and I'll be back with the latest the moment there's more to share. Stay curious, stay informed, and I'll see you in the next one.